Now, we're going to solve for volume in this next problem, right? So if you look at number 5 right here, let's go ahead and solve for volume. Now, what I'm going to do is tell you all, again, you all know we're still talking about the ideal gas law, okay? Because we're looking for volume, the formula is nRT over pressure, all right? So let's read this problem. It says a suspect used 2.0 moles of propane gas to fuel an accelerant-based fire. If the fire reached a temperature of 450 degrees Celsius, also 723 Kelvin, and the atmospheric pressure was 1.02 atms, what volume would this gas occupy at the moment of ignition? All right, that's the formula that you're going to use. Let's plug in the numbers. 2.0 moles times your gas constant. Let me make this a little bit smaller. 0.0821 liters. Again, y'all may get tired of seeing these units, but I'm telling you, the units will guide you. All right? The units will guide you. 723 is your temperature divided by your pressure, 1.02 atms. All right, now I am going to have you all look at this problem right here, okay? So that you all can tell me what we are working with within our problem. We know that we're getting rid of the moles, we're getting rid of atms, we're getting rid of Kelvin. What's left over is your volume unit for liters. Just plug all those numbers in and divide by what's on the bottom, and you should get your answer. 2.0 times 0.0821 times 723 divided by 1.02, and you get 116. Now, if your teachers say, keep the sig figs in check, 116, okay, for your volume, would actually become 120 liters because 2.0 has the smallest or least amount of significant digits. All right. So this is why you would want to make sure that you look at your sig figs. And if your sig figs are very important, then 2 significant digits is what you will work with. 120 gives you your 2 sig figs. All right. Now, we're going to do one more before I give you all a quiz, a multiple choice quiz, okay? And we're going to look for pressure in this next problem because we haven't done a pressure problem, okay? We've so far, let me recap so that way you all can see. We've done pretty much of everything within our formula sheet, okay? So these are the formulas for your reference that you should be using for the gas laws. So the first problem that we did dealt with calculating molar mass. Second problem that we did, we were calculating the grams, the mass. Third problem, we were dealing with density. Fourth problem, the moles. And now we are on, and then we did volume. Now we are on pressure. Okay, so since we are solving for pressure, we already know we're going to use the regular ideal gas law, all right? The regular ideal gas law, meaning PV equals nRT. But since we're looking for pressure, pressure is equal to nRT divided by volume. All right, so let's go ahead and look at this problem now. A victim was found in a small 500-liter airtight closet. If 15.0 grams of carbon dioxide, if 15.0 grams of carbon monoxide were released into the space at 295 Kelvin, what was the pressure exerted by the toxic gas? Carbon monoxide is very toxic. And the thing is, in order to solve this problem, you have to use the moles. Nothing in here says moles straightforwardly. You would have to know that the grams that's given and the molar mass that's given, those two would go together in order to calculate the N right here for your moles. And if you remember, if we go back up here, okay, this is one unit, or not unit, but this is one formula that we could use in moles times molar mass, okay? But you have to reverse this to solve for your moles. But y'all, again, to solve for our moles, you should just go back a couple of weeks ago where you take your 15 grams. So I'm going to actually do this right here. And you're going to take your 15 grams. Okay. And you got 15 grams of carbon monoxide. And you're going to convert that to a mole. 1 mole of carbon monoxide is equal to 28.0 grams of carbon monoxide. So you are using the molar mass here that I am providing you with. If your professor gives it to you, chances are you're going to use it to solve part of the problem. Your grams of carbon monoxide goes out the door. Let's go ahead and divide that. That's going to give you about 0.5, roughly 0.47, something like that. Because, yeah, you'll see. 15 divided by 28.01 gives us 0.53. But we're going to round this off to 0.54, okay, for sig fig purposes. So 0.54 moles of carbon monoxide will go right there in the first number, okay? So right here, you're going to get 0.54 moles. And then you're going to multiply that times your gas constant. Again, you got to remember your gas constant is 0.0821 liters dot atm moles dot Kelvin times your temperature. The temperature in your problem is 295 Kelvin divided by the volume that they gave you right here, 500 liters. Now, again, you need to also be aware of the trick of how your teachers could give that to you in milliliters. You just have to remember to cancel out your like terms. All right? So far, I hope that you guys are picking up what we are putting down. Now, I'm going to plug these numbers in. 0.54 times 0.0821 times 295. I'm going to then divide that by 500. This is my pressure in ATM, 0.0261. We only need 2 of those numbers, so 0.026. ATM. Now, I know some of y'all would think, well, okay, why not 1 sig fig? Well, in all actuality, this number technically would give you the 1 significant digit. If we're going to go all the way to the nth degree of having our sig figs in check, technically speaking, we're going to do that properly and just say 0.03 ATMs. I want to make sure that I am honoring what we do in chemistry each and every time, because I know that so many professors are sticklers like I am for the sig figs, okay? So your answer here is 0.03 ATM. Now, what I could actually do in a problem like this for my General Chem 1 students, I may say convert that number to a Torr, all right? Convert 0.03 ATMs to a Torr. Well, you have to remember what a Torr is equal to, all right? So I know from what we did yesterday, even though this problem did not ask us to do that, I am just challenging you guys to know to expect this to be the case for your professors, all right? 0.03 ATMs, converting that to a Torr. We know that 1 ATM is equivalent to that. So you're going to multiply 0.03 0.03 times 760 torr. And you should end up with 22.8. All right. Now, let me say this too. Torr, 22.8 torr. Because it is quiz time, I want you guys to write your answer, the letters down in the comment box, okay?